So we're going to look at isosceles and equilateral triangles. An isosceles triangle has at least two congruent sides. Those sides are called the legs. So here's the two legs. They are congruent. This is an isosceles triangle. The angle at the top, which is between the two legs up there, is called the vertex angle. And then you have two legs. The other side's called the base. And the angles at the bottom of the isosceles triangle that's drawn with the base on the bottom, those are called the base angles. So two congruent legs, a base, two base angles at the bottom, and the vertex angle across from. So we're going to construct an isosceles triangle. So the first thing you do is draw a line segment, and that's going to be the base of your isosceles triangle. So got one down here. Then you're going to construct the perpendicular bisector of the base. Remember, with a perpendicular bisector, you take your compass, you put it on the end point, and you stretch the compass more than halfway. And draw a semicircle. Then without adjusting your compass or messing it up, you move it to the other endpoint and draw a similar semicircle. And these two X's form our perpendicular bisector. So then you just take your straight edge, combine those two X's. Draw the line connecting those two X's. So that line is the perpendicular bisector of the base, and that's really about all there is to an isosceles triangle. You pick any point you want on this perpendicular bisector. Pick a point. I'm going to choose one way up here. That becomes the vertex of your isosceles triangle. So you just have to draw the two sides. So you go from that point and now you have an isosceles triangle. These two sides will be the same length. Remember, you can always use your compass to check lengths. You just stretch it out. And then that should be the same length that way, which is pretty close. I think I just messed up a little bit. So there's the length, and there's the length. Yeah, they're the same. So yes, that's an isosceles triangle. So draw the perpendicular bisector, pick any point on it, draw the two sides. There's your isosceles triangle. So if two sides of a triangle are congruent, or you can say if a triangle is an isosceles triangle, then the two angles that are opposite the sides, they're also congruent. This is called the isosceles triangle theorem. If you have an isosceles triangle, then the two angles that are opposite those sides, which in the very first slide of our notes, we called those the base angles, they're congruent. So the base angles are congruent for an isosceles triangle. So we can go through a proof. Since here's a construction, this is an isosceles triangle. We know it's an isosceles triangle because we constructed it that way, just like we just learned. So that means AB is congruent to AC. AB is congruent to AC. It's a given because this is an isosceles triangle. D is the midpoint of BC. That's also given because we did the construction. When we do the construction, that finds the midpoint. So D is the midpoint because we constructed it that way. So if D is the midpoint, that means two segments are congruent. The segment to the left and the segment to the right. BC, nope. Is congruent to CD. Since it's the midpoint, these two segments are congruent. That's the definition of midpoint. And from the drawing, we also have side AD is congruent to itself. AD is congruent to AD. That's the reflexive property. So we have two triangles. We have an isosceles triangle, but we split it into two triangles. And now we have that those two triangles are congruent because of side, side, side. The triangle ABD is congruent to triangle ACD because of side, side, side. And the statement we're trying to prove is that the angles opposite those sides, these base angles, angle B and angle C, we're trying to prove that they are congruent. If the two triangles are congruent, that means that angle B will be congruent to angle C because those angles are corresponding. The corresponding angles of the triangles, and if the triangles are congruent, everything's congruent. So the five letters are C, P, C, B, C. Corresponding parts of congruent triangles are congruent. C, P, C, T, C. So since the triangles are congruent, everything about them is congruent. So yes, the base angles are congruent. So an equilateral triangle is a triangle with three congruent sides. Isosceles has at least two congruent sides. Equilateral triangle have all three congruent sides. Equiangular means that all three angles are congruent. And it's actually true that if a triangle is equilateral, then it's also equiangular, and vice versa. If a triangle is equiangular, then it is an equilateral. So if all three sides are the same, the three angles are the same. If all three angles are the same, then the three sides are the same. So either way, you know that it is true. It's kind of like the Isosceles Triangle theorem. Two congruent angles means the two sides are congruent, and vice versa. Now it's just applying it to all three sides and angles. So here is an equilateral triangle, which means all three sides are the same, which also means all three angles are the same. That's the length of each side. So if all three sides are the same, that means these two have to be the same, because that's two of the sides. So you set them equal to each other. And solve for x. So subtract the 4x over, you get 2x. Add the 5, you get 12. X equals 6. Make sure you answer the actual question, which is, what is the length of each side? X is 6. That's not how long the side is. We got to plug it in and figure it out. So plug in 6. 6 times 6 is 36. Minus 5 is 31. 6 times 4 is 24. plus 7 is 31. They should be the same because we were told it was equilateral. So each side is 31 units. So down here we have a triangle. These two sides are congruent, which means the two angles that are across from them, the two base angles, are also congruent. And all three angles of a triangle have to add to be 180. So we have x plus 3x plus 3y plus 3. We don't really want to mess around with this y because we don't want an x and a y in the same equation. But we know that angle R and angle S are the same thing. So if angle R is x, angle S is also x degrees. Because we know that they're congruent because they are the base angles. So that means that x plus 3x plus x, that's all three angles. X plus 3x plus x. That's the three angles of a triangle, and the three angles always add to equal 180 for a triangle. So that's 5x equals 180. So 180 divided by 5, x equals 36. So now we got to go back and figure out what the measure of angle T is. So if x is 36, P is 3 times 36, which is 108. So here we have two sides are congruent, means the base angles are congruent. So these two angles are the same. So it's like we have 3x plus 3 twice. Plus the third angle. Equals 180, because the triangle always adds to 180. So 3x, that's 6x, plus 5x, that's 11x. 3 and 3 is 6, minus 2 is 4. Then we subtract the 4. Divide by 11, you get x equals 16. But the question is, find the measure of angle P. So we plug in the 16. Remember, P and Q are the same. So if we plug in 16 times 3 is 48, plus 3 more. 48 plus 3 is 51 degrees. So here we have a triangle. All three angles are marked as being the same, which means all three sides will be congruent also. So we have 3 over 10y plus 9 equals 4 over 5y minus 1. So add the 1 over, we get 10. Subtract 3/10. First, let's make this be common denominator, have a 10 on it. So that's 8 over 10. We're going to subtract 3/10. So that's 8 minus 3 is 5/10 y. So we would multiply by 10, that's 100. Divide by 5, we get y equals 20. Minus 1. Plug it in, we get each side is 15.